The last three videos was purely theoretical. We try to understand the original documentation of Ultralight EV1 manufactured by NXP. From this video onwards, I'm going to show you the real Ultralight EV1 card. So to do that, I have written a software which is written in .NET, and as you can see in the video on the corner, so this my PC is connected to a RFID reader. Everything is inside a box, and I have used in this box I have used a RFID reader based on the PN532. So you can buy this from eBay or Amazon.com. These are available at various prices, and you can also use a similar, a card based on PN532, and I think this is manufactured by the ADF route, and this one is a little bit bigger. So as you can see, it has got a very good antenna. So this card has got some advantages, and you can also use the cheapest one, the MFRC 522. Even this RFID reader can also read and write Ultralight EV1, and these are the cheapest one you can buy in Amazon.com and on eBay. And you can also buy, or you can also use the reader writer based on PN532, and this one is a shield. It just stacks on top of the Arduino microcontroller, and these are cost wise, they are expensive compared to the other one. Okay, so it all depends on what you want to do. So all these four shield or modules, they all support ultralight EV1. So I'm going to place a new ultralight EV1 card, which I bought this from a website called Rapid NFC, and I'm going to click on a select. So this software, what I've written, recognizes this as a ultralight EV1 card, and if I click on the go button, you can see that it is going to read all the 16 pages. Okay, and we have gone through this in the documentation about various the organization of the memory structure. So we have seen there is something called OTP, and there's something called as a lock. In fact, this lock is also called as a static locking. And you can also, we have seen there's a configuration pages. There are two configuration pages. So one is the config 0 here, and the config 1. I'm going to explain how to use all this configuration data. And we know that there's a password. You can change the password, you can authenticate, and when authenticate, the pack value is returned here. And we've also seen there's something called VCSL command, which takes a 16 bytes identifier and it returns 4 byte cap. I'm going to show you how this thing works as well. And we also know that this tag supports the originality check, and which is present here, the ECC, the 32-byte ECC signature, which is over here. So, and this is the specification of the card, and we know that there's a command that returns 8 bytes of data. This also here, and we also know there are 3 counters which I'm showing here. So all these things are fetched. So when I click the go button, so the next thing is I'm going to take you through each of these areas, okay, in detail. And so the simplest is, or before that, so as you can see here, this tag has got altogether 16 pages. So 16 tag user pages, sorry, up to here 16 pages. And so let's go through this one at a time. So we know from the documentation the first 2 pages consist of the UID. So the UID of this tag is shown here on the top, and somewhere in the first 2 pages these UID is present. So following from here, so 04 matches the 04, 89 matches 89 here. So the first 2 pages is the UID. So I've also shown here, okay, just let's say, to help users, what these two pages are. And the page number two, actually, because numbering starts from zero, so even though physically this is the third page, but the number wise this is page number two. So this page consists of the first 2 bytes are reserved for internal purpose, and these 2 bytes. So these, as we know from the documentation, these are for the locking bytes. So the default value of the locking bytes are 00. So after that, we got the OTP. So the page number 4, this is the OTP, and this is supposed to be 000, but so when you buy these cards, you have to tell the people where to buy this from to set to keep this as 000, because I did not mention this. So I got this card, with the default NDEF record. So here it's okay, but when you want something very clean card, you have to ask the supplier. So following from page number 4 up to here, so this is where we can write our data. So this is called as the user memory or user pages. So you got page number 4 to page number 15. So this you can read and write whatever you like. So following that, we know from the documentation, this page is the configuration 0 page, and this one is the configuration 1, followed by the password and followed by the pack. And after this there are 3 more pages which we cannot address, so that's the reason why I cannot show here. So following this, keep in mind there are 3 more pages with the 24-bit counters. So the 3 counters follows this the last pages.